Today I'm going to be doing a problem from Chapter 3 on page 76, number 30. A place kicker must kick a football from a point 36.0 meters from the goal, and the ball must clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground with a velocity of 20.0 meters per second at an angle of 53 degrees to the horizontal. We're going to be looking for two things in this problem. So first, it's A, by how much does the ball clear or fall short of clearing the crossbar? And the second part is B, does the ball approach the crossbar while rising or while falling? Like usual, we want to start out our problem by drawing a picture and filling in all our givens. We know that the distance between the football player and the goal is 36.0 meters in the horizontal, and the vertical distance from the ground to the top of the goal is 3.0 meters. We know that the ball is being kicked at a 53-degree angle and that the initial velocity is 20.0 meters over seconds. We want to label where our positive x and y are, and so our positive x is going towards the right, and our positive y is going upwards, and our 0 is right where the ball is being kicked. For this problem, we have to separate x and y, so it's helpful to organize our information in this kind of chart. I filled in all the givens, so we know that in the x direction, the distance between the football player and the goal is 36.0 meters. And because the velocity doesn't change in the x direction, we know that the acceleration is 0 meters over second squared. And in the y, gravity is working to pull the football downwards, so the acceleration is negative 9.8 meters over second squared, because we define down as negative and up as positive. The first thing we want to do in this problem is solve for the initial velocity in the x direction and the y direction. To solve for the initial velocity in the y, we're going to use our sine equals opposite over hypotenuse equation. Once we calculate that, we know that the initial velocity in the y direction is right around 16 meters over seconds. To solve for the initial velocity in the x, we're going to use cosine equals adjacent over hypotenuse. And when we calculate that, we find that the initial velocity in the x is right around 12 meters over second. After we solve for those values, we're going to put them into our chart. So we know that the initial velocity in the x is 12 meters over seconds, and because there's no acceleration, the final velocity is also 12 meters over seconds. For the y, we solved that the initial velocity is 16 meters over seconds, and we'll be solving for the final velocity in part B. So again, in part A, we're going to be solving for the displacement in the vertical direction of how high the football goes to see if it clears the bar, which is 3.0 meters high. To solve for the displacement in the y direction, we'll need 3 pieces of information, but unfortunately we don't have that. So instead, we're going to look at our x values, solve for time, and use that time to find the displacement in the y. We're going to use the kinematic that is displacement equals initial velocity times time plus half of acceleration times time squared. Again, to solve for time, we're going to be using the values from the x, and because there is no acceleration in the x direction, it's 0, and we can completely get rid of this portion of the equation, and we're left with this. We're going to manipulate the equation so that we're solving for time. We can then plug in our values, which are 36 meters and 12.04 meters over seconds. And then if we put that into our calculator, we get 2.99 seconds. We want to put that information into our chart so we know that the total time in which the ball goes from the ground to the goal is 2.99 seconds for both x and y. In order to find whether the football will clear this 3.05 meters high bar, we want to first find how much displacement it'll go in the vertical direction on its own. I'm going to be using the same kinematic equation that I did from the earlier part of this video, except for this time around, I'm going to be plugging in numbers from the y portion of our chart. When we plug in all our values, this is the answer we're going to get. I actually used more precise numbers for this calculation just to avoid some serious rounding errors that could really affect our final answer. So now we know that the football travels 3.95 meters from the ground. Because we know that our football traveled 3.95 meters above the ground and the bar is only 3.05 meters, we know that the ball did indeed clear the bar. And we can find how much the bar was cleared by the football by subtracting the displacement in the vertical direction of the football by the height of the bar. And when we solve for that value, we get 0.9 meters. Just to remind you, B is asking us to find whether the ball is approaching the crossbar while rising or falling. To find whether the ball was falling or rising when it cleared the crossbar, we need to find the final velocity. Because we defined our y direction upwards as positive and our y direction downwards as negative, when we get our final answer of our final velocity in the y, if it's positive, then the ball was rising, and if it's negative, the ball was falling. To find the final velocity, we're going to use the kinematic final velocity equals initial velocity plus acceleration times time. And we're going to use the values from the y portion of our data. And so when we solve for that, we get that the final velocity is negative 13.3 meters over seconds. And we can conclude that final velocity in the y direction is negative. Knowing that the final velocity in the y direction is negative is going to help us determine whether our football was rising or falling. Like earlier, we concluded that if final velocity y is positive, then it's rising, and if final velocity in the y is negative, then the football's falling because of how we defined our positive y and negative y. And so we can conclude that our ball is falling because final velocity in y is negative.